This is the homework video for 41017, and I put the homework packet for those of you that use OneNote into the Unit 6 homework packet, and it'll say 410 through 413. And if you're using the hard copy, then it's the one that says Monday. You're supposed to sort these into linear tables, nonlinear tables, linear equations, nonlinear equations, and I'm just going to go through really fast and show you which is which. And then you have to fill out the table down below. So I'm going to start with this one. This table is increasing by 11 here, and it's increasing by 11 here, and increasing by 11 here, and by 1 here, and 1 here, and 1 here. So this is the rise, 11, and this is the run, 1. And so if you divided the rise by the run, then you would get 11. And so the equation is y equals 11x plus 10. And I got the 10 because that's the y-intercept, where x is 0, y is 10. This is the slope in front of the x. This is the y-intercept. This is a linear table. So it should go in the linear column. And then I'm going to go to the next table, B. This is increasing by 1, and then from 2 to 4 by 2, and 4 to 8 by 4. On the X side, which is the run side, it's increasing by 1 all the way down. And if you did the rise over the run, the first one would be 1 over negative 1, which simplifies to negative 1. The second one would be 2 over negative 1, which simplifies to negative 2. And the last one would be 4 over negative 1. And that simplifies to negative 4. Because there's no constant rate of change, this goes in the non-linear table part, because there's no constant rate of change. Then the next table, C, this is first one's from 5 to 1 is going up by 6, and then from 1 to 6 is going up by 5, and then from 6 to 11 is going up by 5 again. All of the x's are going up by 1. 6 divided by 1, or rise divided by run, does not give me the same answer as 5 divided by 1, which means there's no constant rate of change. Notice that I'm taking the change in y numbers, 6, 5, and 5, and dividing them by the change in x numbers, 1, 1, and 1. I am not dividing the y by the x. Some of you are still doing that. You need to stop doing that now. It's the change in y divided by the change in x. This is also non-linear. There's no constant rate of change. On my last table, this is 4 from negative 5 to 1, and then from negative 1 to 3 is 4, and from 3 to 7 is 4. And all of these are going up by 3, increasing by 3, which means the equation is y equals 4 over 3x minus 5, where 4/3 is the slope, and negative 5, where x is 0, is your y-intercept. This goes in the linear column. And then now let's look at the equations, and I'm going to start over here. The first equation is y equals negative 2/5 x, and the slope is negative 2/5, and the y-intercept is 0. That's linear. Notice that the x is, you don't see any number that the x is being raised to, which means it's being raised to the first power, and so that's definitely linear. On the second equation, I have a nonlinear because it's 2 plus 5x squared. The x is being raised to the second power, and so that is not linear. On this one, it's y equals 9 plus 3x. The x is being raised to the first power. The slope is 3, and the y-intercept is 9. This is a linear equation. And on this one, y equals 1/2 x minus 4. The x is being raised to the first power again because you don't see anything by it. The slope is 1/2. Whoopsies, sorry. The slope is 1/2, and the y-intercept is negative 4. This is a linear equation. So out of all 4 of these, this one is nonlinear because of this squared next to the x. It can't be raised to the second or third or fourth power. It can only be raised to the first power. Now I'm going to go over here, y equals negative 2 over x. This is non-linear because it's being divided by x. On the next one, y equals negative x. This is linear, where the slope is -1 and the y-intercept is 0. And then I'm going to jump over to this one, y equals negative x squared minus 5. This one is non-linear, and I hope that you realize that the reason why is because it's raised to the second power. And then here I have y equals negative 4/5 x minus 2. That is linear because the x is being raised to the first power, and the slope is 4/5, and the y-intercept is -2. And on the last equation, it's linear because it's y equals 9 minus 3/5 x. Not 3/5, sorry, 3.5x. The negative 3.5 is my slope, and the 9 is my y-intercept. And it's linear because the x is being raised to the first power. The secret message is that any equation that's being raised to where x is being raised to the first power is linear. Any equation where x is being raised to the first power is linear unless it's being divided by x. So for instance, on this one, it was being divided by x. Okay, make sure you have the secret message, and hope you have a great night. I'll see you tomorrow.